The next few problems deal with rational expressions and what we're going to do with them. So we have a division problem, we have an addition problem, we have equations. So do I just start dividing? Well, in a way, but what do we do with fractions when we divide? As I'm writing this out, think about it. I change it to multiplication of the reciprocal. And do I really multiply all that out? Kinda, but not exactly. What we really want to do is we want to factor and reduce. Okay, so we've got lots of things to factor. So I'm going to start with this top one. Leading coefficient of 1, that makes it easy. What multiplies get negative 12, adds get negative 4, negative 6, positive 2. No, it does not matter what order you write them in. Okay, so here I've got a coefficient of 1. So again, just say what multiplies get negative 6, but adds to get a negative 1. That would be negative 3 and positive 2. Multiplied by. Now that is the difference of two squares. This is weird. It's just a GCF. What are those both divisible by? 3 or negative 3. If you just take out a positive 3, which is okay, you're dividing each of them by 3, I would have 6 minus x. Now I have factored, I've got to reduce. Do I have any of the same factors on the numerator and the denominator? Well, yes, I do. The x plus 2's, I've got an x minus 3. The question is what about those two? Well, those aren't the same, they are opposites. And so I can reduce them, but I'm left with a factor of negative 1. And I think that's all I can reduce. So I have this negative 1 times an x plus 3. And what's the only thing I have left on the bottom is a 3. So that's an acceptable answer. Probably be prettier if I don't write the 1. Okay. I could also leave the negative on the bottom. Either way, I would be very careful and leave those parentheses. Just a little bit safer that way. Now that's dividing. So remember, we want to factor and reduce. How do we add? Well, think about how do you add fractions. Just like on number 5, how do you divide fractions? You take the reciprocal. How do I add? I have to find that least common denominator, the LCD. I do that by factoring each of these denominators. So I'm going to factor that one, and I'm going to factor this one. So what would be the least common denominator? Well, it's one of every kind of factor. So I have an x minus 4, an x plus 2, and an x minus 5. No, I don't write down that x plus 2 twice. So I'm going to make it one long fraction, one big denominator. So that's my least common denominator. So let's look at this fraction. What part of the denominator from between here and here, what's missing? The x minus 5. So really I'm going to multiply the bottom by x minus 5 to make it match, which means I have to multiply the top by x minus 5. So I have 3x times x minus 5. And I have plus, and I'm going to do the same thing here. If I look at this and I compare it to this denominator, what does it not have? The x minus 4. So I would multiply by x minus 4 on top and bottom. Okay, so at this point I'm going to keep this big old ugly denominator. Please do not multiply all that out, not necessary. But I do need to distribute the top part. And then I'm going to collect like terms on top. So I have 5x squared minus 23x over that very, very ugly denominator. Now this is the part you go, can I do more? I hope not. Could I factor that? No. You could take out an x and that would be okay, but would it reduce with any of these down here? No. So yes, you could factor it, but it wouldn't really do you any good. So I'm just going to leave it like that. Okay, so now we have divided rational expressions and added rational expressions, which are just big old ugly algebraic fractions. Now we have fractions within fractions. How am I going to simplify that? Well, there's a couple of different methods, but this is my method. First of all, I'm going to rewrite this problem by putting these values over 1. Now I need to find the least common denominator out of the whole big picture. Well, really, I have an x, a y, and a 1. So the LCD is an xy. So I'm going to multiply the numerator and the denominator by the LCD. And that's really multiplying by 1. So I'm going to distribute it to the top and bottom. So I'm going to have y over x times xy over 1 plus x over 1 times xy over 1. Then x over y times xy plus y over 1 times xy. I know that looks really ugly, but what I'm going to try to do is I'm trying to get rid of all those 4 fractions and just get it down to one ugly fraction. So those reduce, and now all I have in the denominator is 1. And I don't need to write the 1, so I'm just going to multiply that together, y squared. I'm going to multiply that together. On the bottom, can reduce that, and again, all I have are 1's in the denominator. So just multiplying that, I have x squared plus xy squared. I can leave my answer like that, or I could say, hey, I could factor out, what do I have in common in the top? A y. What do I have common in the bottom? An x. But I can't reduce either of those, so again, this would be an okay answer, this would be an okay answer. So our last thing with rational expressions is solving for x. Well, it would be nice to know what that common denominator is and then get rid of those fractions. So I have to find that common denominator, so I need to factor this. And lo and behold, it's the same factors as those two. So look at what we have. Just need a little more space. I'm going to multiply every term by the LCD, and the LCD are those two factors. So I can multiply this one by the LCD, this one by the LCD, and this one by the LCD. Why am I doing that? Let's see. So I can reduce. Those go away, and all of that goes away. So again, I just have 1's in the denominator, and I don't have any fractions anymore. Now I just have an equation that hopefully I can deal with. So I'm going to distribute. Be careful with that negative. That's going to become plus x. Now I have a quadratic, like the first 3 problems on the review. I've got to set it equal to 0. So I'm going to collect like terms. I'm going to add that 12 to both sides and make it positive, and now I get that 0. And now I'm going to factor. I think that works if those are all pluses. Just going to take a second and check. Do I get 13 in the middle? Yes, I do. And again, whatever factoring technique you use, we should get those same factors. Now I set each factor equal to 0 and solve. So subtract 4 and divide by 3. Subtract 3. Are you done? No. You have to check your answers back into the original denominator to make sure we're not dividing by 0. Okay, I know you're going, ugh, I don't want to do that negative 4/3, but look, let's check negative 3. If I put negative 3 in right there, negative 3 plus 3 is 0. I cannot divide by 0, so I have to throw that out. And I could put it the same place. But what about this one? If I put it in for x, is negative 4/3 minus 1, is that equal to 0? You don't have to figure out what it is, but is it equal to 0? Well, no, of course not. Two negatives can't be a 0. If I put it in there, is negative 4/3 plus 3 equal to 0? No, because we just saw it has to be negative 3. And then these things are the same as those two. So this is an okay answer to keep. So my solution is negative 4/3. The negative 3 is an extraneous solution, not part of the solution.